So last time when we were together and we went through 14.1, we talked about 3 types of voting. So there's lots of other types of voting, but we're just like we've done with everything in this class. We're doing a nice surface level, quick skim through all these things. So the types of voting that we talked about were just the plurality method. What was the plurality method? How do you determine the winner given the plurality method? Most votes, straight away. That's it. Okay, and then the alteration to that is plurality with elimination. How do we? What are we seeking to find, or what are we hoping for with the plurality with elimination? You want somebody with a majority, which is over 50%. So if you don't have a majority, then you cross off the way we're doing it, okay? Because there's other ways to do it, but the way we're doing it is we're crossing out the bottom option, and then we're revoting, or we're looking at that. And then the last one was the board account method. In the board account method, you assign points based on how many first, second, third, fourth, fifth, whatever place votes. Okay, so there are some mathematical contradictions that can sometimes happen in voting. So that's what we're going to talk about today. So there are 3 flaws that we're going to talk about to go with our 3 types of voting. So the first one's called the majority criterion. And so what we hope for in any sort of vote or any sort of election is that if a candidate receives a majority, that's why it's called the majority criterion. So if a candidate receives a majority of the first place votes, what we would hope is that that candidate should be declared the winner. So we're just going to use this section. In addition to talking about these flaws, it gives us a quick and easy way to review the voting methods so that you can be ready to rumble next time or a week from today when we take the test. So here's my example, then I've got one that's just like it for you. And if you have any question at all about what the majority criterion is, please let me know. So this example here that we have, the members of this town council are holding an election to select a company to maintain landscaping in the public areas. The choices are green landscaping, the letter G, lawn heaven, letter L, and jubilant gardens. Everything sounds so happy, letter J. So that they voted according to the table below, so we can see our preference table, which we talked about last time. So we're just going to do 2 things. First thing is we're going to determine the winner by the board account method. And then we're going to look at, okay, does that agree with who got the majority of votes? If anyone did. If no one got a majority, then the majority criterion doesn't even apply. Okay, but if somebody did get a majority, then hopefully these 2 things align. So here we go. So remember our board account, what we're going to do is we're going to look at, I'm just going to go in the order they're given. We're going to look at G, green landscaping. And so green landscaping, remember, got 7 first place votes. What do I multiply that 7 by in my board account method? 3. Yes, we give the, because we have 3 options, and I'll just write this right over here, we're going to give all the third place options 1 point, the second 2 point, the first 3 points. So that's 21 points so far, and then G got 2 second place votes, and so I'm going to multiply that by 2. So 2 times 2 is 4 more points. And then G got 4 third place votes, so that's 4 times 1 or 4 more points. And so green landscaping totaled 29, according to the board account method. If I'm running through the arithmetic too fast for you, please let me know. I'm just having a good time up here. But I don't want to lose anybody. We did this last time. I think everybody was here, but if you weren't here, this is what we did last time. Hope you watched the video. Okay, next one is lawn heaven. So L. So L got 6 first place votes. So that's 18 points. L got 7 second place votes. And then L did not get any third place votes. And so that is 32 points. And then finally, Jubilant Gardens. J got 0 first place votes. J got 4 second place votes. And J got 9 third place votes. So according to our board account, who wins? Who's going to get this contract? L. Now, if you remember when we were talking about border count, I said border count is easy to manipulate. That's why it's not widely used, because people haven't figured out a way to counteract that. Although I did tell you that I think it's Maine, a couple of the other small states, a lot of times for local elections, this is used because it gives people more feeling of choice. So Lawn Heaven is going to win. So then who got the majority? So the B part to the problem is who got the majority. Well, there are 7, 11, there's 13 people voting. And when we divide 13 by 2, that is 6.5. And so the majority is what? Mentioned last time, a majority has to be more than half, not equal to half, so more than. So since half the votes would be 6.5, the majority is going to be 7. It's always just the next whole number above the halfway. Did anybody get 7 votes?
Yes.
G got 7 votes, so G got the majority. Now again, I just want to reiterate this, because we saw many times when we were doing our plurality with elimination, the first time around, it was quite common that no one got a majority of votes. So if no one got the majority, there's no contradiction. Okay, so if there's no majority, no contradiction. If L had gotten the majority, there's no contradiction. And so what this means is that, hang on, G got the majority of votes, but then G was also either loved them or you hated them kind of deal, because they not only got a lot of first place votes, they got a lot of third place votes. So G got the majority, and so what we would say here is that this is a contradiction of the majority criteria. The reason it's a contradiction is G got the majority, but L won by the election method. And in political science and math, they teamed up because math people are awesome. They determined that this majority criteria should hold in elections. All right, so that's the majority criterion. That's my example. You're going to do the same sort of thing with yours. I've never done this example. I just picked it out of the book this morning. So I don't know if this one, if it's a contradiction or not. So you are going to determine that for me. So do the same thing. Determine who wins this election by the board account method, and then determine who got the majority and if there is a contradiction. I'm just going to get started with the arithmetic here. Keep working. Okay, I'm not trying to rush you. I'm just trying to not bore you when we're all done with the problem. Okay, so I'm going to get started. Okay, so just going through it real quick. So for A got 6 first place votes, 0 second, 0 third, and then 5 fourth place votes for a total of 29. B got 5 first and 6 second for a total of 38 points. S got 4 second, 6 third, 1 fourth place vote for a total of 25. And Y got 1 second, 5 third, 5 fourth for a total of 18. So by the board account method, B should be the winner. Anybody get something different or anybody struggling to remember the board account method? So I'm just going to put this right here, something just like this on the test. Okay, I want to be able to do that with all confidence that you're going to feel good about it. All right, so then a majority, there were 11 votes in this election, divided by 2, that's 5.5. So that means a majority is more than half. So a majority is 6 votes. Did anyone get 6 votes? Well, yes, A got the majority. And what we see is that is a different person got a majority than won by the board account. So once again, this contradicts the majority criteria. It doesn't always happen, okay, but I guess for our 2 examples, it did happen. Okay. Any questions about what it means to violate the majority criterion? All right, well, then we're going to go to the second one, the second of potential flaw or contradiction in voting. It's called the head-to-head criterion. And the head-to-head criterion says if a candidate is favored when compared head-to-head with every, I'm going to underline the word every, I should have done that. So the head-to-head criterion only applies when somebody is favored when they're compared with every candidate. That candidate should be the winner. Okay, so individually, if you are a candidate and you beat everybody one-on-one, then you should win the election. So example 2. I've got 4 candidates running for mayor. I'm just going to say A, B, C, and D. The election results are below. So is there a candidate who is favored over all the others using the head-to-head comparison? So again, the head-to-head comparison only applies if it happens. Just like the previous one, that criterion only applies if somebody got the majority the first time around. The head-to-head only applies if somebody wins head-to-head first time around. If not, all bets are off. Okay, so let's see. How do we determine if somebody beats? So I'm just going to start alphabetically. So I'm going to start with A and B. and we're going to compare A and B and see how they do head to head. So A and B. What we're going to do is we're going to go through each column and see how many times A beats B or vice versa. So in this first column, now again, we're just comparing A and B. We don't care about anybody else at this point. Who wins these 129 votes, A or B? A. Why does A win the votes? Yeah, A is in second and B is in third. Again, we're ignoring all the others. We might have to come back and compare A and D and B and C, whatever. We're just depends on what happens. So far, A has 129 votes. Next column, who wins these 90 votes, A or B? Okay, again, A was first, B is third, so A. Next column, who wins these 87 votes? B does. B finished before A. Everybody see why I'm drawing these conclusions? In the fourth column, who gets those votes, A or B? B finished second, A finished fourth, so that those 78. And last but not least, who gets these last 42? So now we'll add up. So A in this case got, what's that, 219? And B got, what's that, 5, that's 165, that's 207, I think. You should definitely check that. And so far, A beats B. Now, as you're doing this on your homework and you're like, what do I do next? Well, remember, the head-to-head criteria only counts if somebody beats everybody head-to-head. So I no longer care about B because B lost. Right? So B can't win versus everybody, but A still has a chance to do it. Okay, so now I'm going to check A compared with C. So go ahead, take 30 seconds. Okay, I'll step through it in just a minute, but go ahead and compare A and C and see who wins between those two.
So you sort of the two randoms.
Yeah, I just went alphabetical. Yes. So where did I start? I just picked A and B because alphabetical order. That's that only. I have no secret, mysterious reason. I promise. Okay, so again, just to talk through the procedure, I just picked A and B first, alphabetical, and I saw that A won. Now, if B had won here, okay, if B had been the greater, then I would have done B and C, okay? Because again, head to head, it has to win versus everybody. If they lose any individual one, they're out of the running. So A and C. So I've got A, it actually turns out to be the same numbers. That's coincidental. That doesn't always happen. So A got 219 points. C got 207. So again, A wins. Now again, if C had won this, then A is out of the running because you have to beat everybody. And then I would check C and see how C did compared to B and C did compared to D. Okay, so it only matters as long as somebody beats everybody. So let's do next one, A and D. So if A wins this one, then A beats everybody. So that's the head-to-head criteria. If A doesn't, if D wins, then I've got to go check the Ds. Okay, that's just how this works. I'm sorry, it's a little bit of busy work. That's why we're just going to each do one.
What is this method for?
This is the head-to-head criterion. Okay, so again, going through the columns. In the first column, these 129 points, we see D finished first, so D got the 129. The next one, A finished first, so A gets the 90. Here, A finished above D, so A gets the 87. Here, D finished above A, so D gets the 78. And last but not least, A finishes above D, gets the 42. So the totals, again, turn out to be the same. I promise that doesn't happen all the time. But anyway, again, A beats D. So again, I don't have any secret. I've never done this problem. I just pulled it out of the book because the book's made the nice, pretty tables for us. Okay, and it saves me time from making a table in Microsoft Word. But we see that A beat everybody. So the head-to-head criteria applies. A beat everybody. So now the second part to the problem. Who wins the election if we use plurality with elimination? Do the results violate the head-to-head criterion? Okay, so since A beat everybody, what we're hoping for is that A would win with the plurality by elimination. If it does, then we're good to go. If A doesn't, then that would be a contradiction to the head-to-head criterion. Okay, so let's see, plurality with elimination. So let's see, A, B, C, D. If you remember this method, so this is again our review of doing it. So I'm just going to go through and see how many first place votes everybody got. So A got 90 first place votes. B got 87 first place votes. C got 78 and 42, so that's 120 first place votes. And D got 129. Now, before I make any conclusions, I have to see what a majority is. Has anyone added up all of these numbers? What's that? That's going to come out to what, 426? No, I don't think it. Yeah, I think it's 426 because each of these pairs here adds up to 426. But if somebody could just add these numbers across the top and confirm. Okay, thank you very much. I appreciate that. So 426 divided by 2 is 213. So that means a majority is equal to 214. Has to be more than half. Oh, unfortunately in this, no one got 214 votes. So then remind me, what's my process? What do I do next? We're getting rid of B. Goodbye, you're out. And so now, again, what the assumption we make, since we can't do re-elections, we are just going to take the chart and we're just going to give B's votes to the next one on the list. So these 87 votes of B, they are now going to go to C. Okay, so my new totals become A gets 90. C with the 87 has 207 and D has 129. Well, as I would have hoped for a majority, but I got a little bit more busy work to go. So there's no majority here. So I'm going to get rid of A this time. And so A's 90 votes are also going to go to C. So C is really raking them in here. So C now has 297 votes. D stays at 129. And so what we get here is that C wins the election. Yay for C. So does that line up with the head-to-head criteria? Are they consistent? No, because A beats everybody head-to-head. So according to the head-to-head criteria, we would hope A would win the election. They did not. So yes, this contradicts the head-to-head criteria. All right, you have the same thing to do in exercise 2. So go ahead and take a couple minutes and do what you can and make sure that you feel good about the plurality with elimination method of doing votes. And we will compare notes in just a minute. All right, I'm gonna get started on this. You're probably way ahead of me. I'm gonna start with A and B like I did before, because again, I've never done this problem. You've done more of this problem than I have, and so we'll compare notes. Okay, so here's where I am. If I'm too far ahead of you, just wave your hand. I'm happy to give you more time. We've got plenty of time today, like I said. Okay, so I just started off. So here's my procedure, my thought process, having never done the problem before. I said, okay, alphabetical order. I'm just going to compare A and B. And A beat B directly, 11, got 11 votes. B beat A in all the other categories and got 16 votes. So far, B's the winner. So now I can throw A out. It can't win head-to-head versus everybody because it didn't beat B. So now I'm going to do B. So B, and I compared B and C, and B beat C on 19 ballots, C won on 8. So again, B, so seems like we've got a contender here. So B won against A, B won against C, so I'm going to try D. And so then B and D, and I got the same thing, B beat D. If C had won, then I would check C with everybody. If D had won here, that would have created the most busy work. I would have then compared D with everyone. Okay, so B beats everyone head to head. If you don't have anyone that beats everyone head to head, then you can just stop right now and say, okay, the head to head criteria is not going to apply. Okay, so now here is my plurality with elimination. I've got my four vote getters. 27 divided by 2 is 13.5, so my majority is 14. No one got 14 votes, so I'm going to get rid of B's. And so B's votes are going to go to C now. So A stays at 11, C has jumped up to 11, and D stays at 5. So the book is really giving us a little bit of extra work here. They could have just ended that early, but they chose not to. So now I'm going to get rid of D because I still don't have a majority. So D's votes are they would have gone to B, but B is already out of the election. So they go to C. And so that means A has 11 votes, C has 16 votes, C wins, and again, the head-to-head criteria is contradicted. We doing okay? So if B had won the plurality with elimination, then there would have been no contradiction. So just making sure that that we're seeing all the different situations. All right, there is one more flaw. So we've talked about the majority criterion. Whoever gets the majority should win the election. The next one was the head-to-head. Whoever wins head-to-head, if that happens, they should win the election. The last one's called the monotonicity. I just like to say that. That's probably why I have this one on here. So it's the monotonicity criterion. And so here's what this says. A candidate who wins a first election and then receives additional support without losing any of their original support should win the second election, which seems to make sense. Okay, so again, if you won the first election, and then there had to be a second because there wasn't a majority or whatever. So if you won the first election, but then then in the re-election you got more support, you should win the second election. So let's see what that means. So here we go. The marketing committee at grocery stores that says conserving. That should say considering. It was a little early when I was typing this morning, so I'll have to fix that. That's considering 3 new services to offer, either delivery or self-serve checkout or catering, so D and S and C, and an initial vote is taken. So you can see the initial vote. But as happens in any committee, this is why I hate committees. After several hours of debate, a second vote is then taken, and these are the results. So you can see there's a change in some people's results. In fact, what happens is these 5 people right here, they changed their vote to here. So looking at the table, we see that those 5 votes get incorporated into that column, and so this last column, instead of 11 like it started, becomes 16. Okay, so here we go. Here's what we're going to do. First, we're going to say using the plurality with elimination, who wins the first? So if they had just decided before all the several hours of debate who was going to win, who would have won the first time around? Okay, so we've got D and S and C. So the first time around, D got 9 votes, S got 11, C got 13. There are 20 and 28 and 33, so there are 33 votes going on here. So let me calculate. A majority is 33 divided by 2 turns out to be what, 16.5, and so a majority equals 17. Well, unfortunately, nobody got the majority, so we're going to get rid of D. No one is getting delivery, apparently. And so when we do that, we get rid of D. Those 9 votes go to S, self-checkout. And so what we get is 20 for self-checkout and 13 for catering. And it looks like self-checkout wins the election. Great. So notice what happens here. And notice why the monotonicity criterion applies. Again, it doesn't always have to apply, just like the majority criterion doesn't have to apply if no one got a majority the first time around. Because notice here, the majority criterion wouldn't have applied to this election because no one got a majority the first time around. The head-to-head only applies when somebody wins head-to-head. If no one does, it doesn't apply. So again, this doesn't have to happen, but notice what happens. S won this election. S increased support. Okay, so I'm just going to draw an arrow. S increased support. That's how come the monotonicity criterion applies. The winner of the first election increased support in the second election. Okay, they got more first place votes. Does that make sense? This one's sometimes the hardest one of the 3 to see. You tracking with me on why that applies? Okay, so now we're going to do a re-election. The B part of the problem says, again, use the plurality with elimination to see who wins the second time around. Okay, so D and S and C. D got 9 votes this time. S got 16. Notice it increased its support. And C has 8. But again, no one has a majority. They're so close to getting a majority. So now what's going to happen is I'm going to get rid of C because I need to do my elimination. And so when I get rid of C, those 8 votes go to D. So now what I have is D has 17 votes, S has 16, and you can see, oh no, S won the first election. S got more support. S lost the second election. So the answer to the C part, does the result violate the monotonicity criterion? Yes, it does. And the reason it does is S did not win after getting more support. All right, so last problem for this section. Same sort of thing. Okay, exercise 3 says, suppose you use plurality with elimination again. So what you're going to do is you're going to do plurality with elimination on that table as it stands right now, the first election. Then I tell you that the 3 people that voted CBA, so this column right here, those people, they changed their vote to BCA. So apparently B is getting more support. Is the monotonicity criteria satisfied, or is it violated? So I'm going to give you a couple minutes to go through that. And this will be the last one, unless you have any questions. I love questions. I'm open to them. Plurality of elimination. So we're going to see how many first place votes, and if no one got a majority, we're going to cross out and do the election the way it stands. Then you're going to change this and do it again, just like we did here. Gotcha. All right, let's see how you're doing. If you got any other questions as follow-up for this, I'm all ears for them. So here goes. So instead, the only difference on this problem is just because I was running out of room and I didn't want to use a whole piece of paper for just another problem. Instead of giving you 2 tables, I gave you a table and then described what's going to happen next time around. Okay, so I could have, probably should have, instead of being lazy, but I was trying to get away with it there. So what we're going to do is we're going to do plurality with elimination on this right here. So let's do it. We've got A, B, and C. And when we start off, A gets 6 votes, B gets 7 votes, C gets 5 plus 3, C gets 8 votes. Majority, since I've got 11, what's that, 14, 21, I've got 21 divided by 2. What does that mean a majority is going to be?
11.
Okay, so the majority equals 11 there. Great. No one got to 11, so A is going away. And so when A goes away, that means B is getting those votes. And so that means now I've got B at 13, C stays at 8, B wins. Congratulations, B. So then what I said up in the instructions is that the 3 people who voted CBA, this column right here, the CBA column, they changed to BCA. So what that means is B, because B is the winner here, B gets more support. B won the first election, B gets more support. Okay, so I'm going to write that down. Okay, B won the first, then B gets more support. So mathematically, what we would hope would happen, this is the monotonicity. Monotonicity, I'm saying it too much, so now I can't say it anymore. According to this criteria, whoever wins the first election, if they get more support, mathematically, we would assume they're going to win the second election. If B won the first election and B did not get more support, so if when we changed this here, if we changed it to C, then the monotonicity criteria does not apply. Okay, so the key for you going into the test is to understand the circumstances under which each of these applies. Okay. So now I'm just gonna rewrite this. So we've got, this is gonna remain 5. Okay, this column ABC, that's going to remain 6. But then in this next election, we're not going to have this column anymore, and there's going to be 10 in this column. Okay, so I've just put the numbers at the bottom instead of at the top this time. Okay. We have no more column here because I said take the CBA, those 3, and give them to the BCA. So we're flopping them over to here. Okay, so now here's the second election, A, B, C. Well, now A still has 6 votes in this column. B now has 10 votes because BCA. And C still has 5. Well, again, no one has the majority. Okay, we need 11. B is really super close, so I'm going to get rid of that. I'm going to use a different color. I wasn't thinking ahead because I often don't do that. So now I'm going to cross out those C votes. Those 5 C votes are now going to go to A. And so that means here's what I've got. A now has 11, B has 10. So again, mathematically, we would assume B would win because it increased support, but it did not. This time A wins. And so is the monotonicity criterion satisfied? No, it's violated. Violated, or you can say contradicted, whatever word you prefer there. No, it's violated because B does not win the second election. There we go.